my dear students. Let's start the session.
Acceleration analysis in rolling, or else first whatever, fine. Acceleration analysis in rolling. Acceleration analysis in rolling. Entire discussion is what? Kinematics. Acceleration analysis in rolling. This is the rolling. Clear? This is the point of contact. This is the point of contact. Point of contact I. Point of contact I. Okay, so ఇక్కడ మనం P అని పెట్టుకో. Point of contact P. Point of contact P. So this is the point A, point B, point C. So it is having linear acceleration A. Linear acceleration A, angular acceleration alpha, linear acceleration A. Rolling is the combination of, it's a combination of, it's a combination of both rotation and translation. Combination of both rotation and translation. Both rotation and translation. Rolling is a combination of both rotation and translation. From rotation, linear acceleration. From translation, linear acceleration will come. From rotation, alpha will come. So here, take this here to here. Now we need to represent same manner. Whatever the velocity analysis we made, same manner acceleration analysis. Clear? So here to here, same manner. This is A, this would be B, this would be C, this would be point P. First, in pure translation, acceleration at any point on the solid disk is same and it is in the direction of motion. Acceleration. See here, what is the acceleration here? This is the acceleration A. This is the linear acceleration. A refers to what? Linear acceleration. Linear acceleration. It is coming to linear acceleration. Okay now, so this is related to translation. Understood? So when acceleration at this point, this is acceleration A only. At this point, what is the acceleration? A. At this point, acceleration is how much? Acceleration A. This is coming to linear acceleration. Now coming to alpha. This is how much A? This is alpha. So now we need to mark radial acceleration. Radial acceleration. At point B with respect to point O. So what is that? Here what we will get? Radial acceleration. This is coming to radial acceleration. Here what we will get? Radial acceleration. Always act towards the center of rotation of the body, center of circular motion. it always act towards the center. It always act towards the center. If you want to take a point Q, this is the point Q. This could be A. This could be A. This could be how much? Radial acceleration towards the center. Towards the center. Understood? Now, in the rotation, we are having two component of velocities. Here, alpha related to the parameter rotation. Alpha related to rotation. Alpha related to rotation. A related to translation. A related to translation. Okay, now alpha related to rotation. In the translation, only A. In the rotation, we are having. We need to represent radial and tangential acceleration. Radial and tangential acceleration. It always have tangentially. Tangentially. This is tangentially. 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 This is how much? Tangentially. Tangentially. This is also tangentially. Tangentially. This is tangentially. So, at the point of contact, no slip condition. No slip condition. Yet no slip condition. Yet no slip condition. Here we are getting linear acceleration equal to tangential acceleration, but acceleration at point of contact not equal to 0 because radial acceleration exists. Understood? Yet no slip condition, velocity at point of contact 0, but acceleration at point of contact not equal to 0. Clear? It is very important statement. Acceleration, linear acceleration equal to tangential acceleration equal to linear acceleration. Tangential acceleration equal to linear acceleration. Alpha r equal to A. You can confidently say that alpha equal to how much? What is the angular acceleration equal to? A by r. A by r. Alpha equal to A by r. We can apply this part in dynamics of rolling. First you should know kinematics. So here, what is the acceleration at point of contact? This is one of the previous year question. Acceleration at point of contact. Acceleration at point of contact P. Acceleration at point of contact P. AP equal to how much? AP bar equal to how much? AP bar equal to how much? A minus AT. A minus AT. I cap. A minus AT. I cap plus AR J cap. AR J cap. Okay, now just now we discussed this part becomes how much? This part becomes how much? 0. This part becomes how much? 0. A equal to AT. Then what is the acceleration at point of contact? Radial acceleration J cap. What is the magnitude of acceleration at point of contact? Omega square r. Omega square r. This is not equal to 0. But velocity at point of contact equal to 0. Acceleration at point of contact is not equal to 0. Acceleration at point of contact is not equal to 0. This part completed. This part done. Now tell me. Now we can write. See this. What is that? చూడండి ఇక్కడ What is the acceleration at? చూడండి ఇక్కడ. See here. What is the acceleration at point A? Acceleration at point A. What is the acceleration at point A? A plus AR. A plus AR. This is how much? I cap. This is how much? I cap. AT J cap. AT J cap. ఇంకేముంది? ఓకేనా? సో హియర్ A plus omega square of I cap plus alpha R into alpha J cap. What is the magnitude of acceleration at point A? What is the magnitude of acceleration at point A? Square root of. Tell me. Omega square R plus A whole square. This is how much? A plus omega square R whole square plus alpha R whole square. That is the magnitude of acceleration at point A. What is the magnitude of acceleration at point B? What is the magnitude of acceleration at point B? Magnitude of acceleration at point B, tell me. A minus AR. A minus AR. I cap. Minus AT. J cap. Are you getting the same? A minus AR. I cap. Minus AT. J cap. So that equals to how much? A minus omega square R. R is the radius of the disk. This is I cap minus alpha R into, so alpha R J cap, not into alpha R J cap. What is the magnitude of acceleration at point B? What is the magnitude of acceleration at point B? Tell me how much you are getting? Square root of A minus omega square R whole square plus alpha R whole square. Getting? So next, what is the acceleration at point C? What is the acceleration at point C? Tell me. Acceleration at point C. That bar equal to how much? Tell me. A plus AT. A plus AT. I cap. A plus AT I cap. Minus AR. J cap. A plus AT I cap. Minus AR. J cap. So now tell me. AC bar. AC bar equal to A plus alpha on I cap minus omega square R J cap minus omega square R J cap. So then what is the magnitude of acceleration at point C? Tell me. A plus alpha R whole square plus omega square R whole square. So here you can take this would be theta. Then this is how much theta? This is 90. This is how much? 90 minus theta. So now we need to talk about acceleration at point P. Acceleration at point P. See here, along this direction A. This is the tangential acceleration. This would be radial acceleration. This is theta. Here to here 90. This is how much? 90 minus theta. This would be theta. Clear? So now tell me, what is this? Horizontal component. Theta ki pakkane ఉన్న component ఏంటి? This is cos component. AR cos theta. This is how much? AR sin theta. AR sin theta. Then AT. This is how much? AT cos theta. This is how much? AT sin theta. AT sin theta. Are you getting the same? This is how much? AT cos theta. AR sin theta. AT sin theta. Finally, what is the acceleration at point P? Acceleration at point P, tell me. A plus AT sin theta. A plus AT sin theta minus AR cos theta. I cap. A plus AT sin theta minus AR cos theta. I cap. Clear? So next minus AT cos theta. AT cos theta plus AR sin theta. AR sin theta. J cap. Okay na? So here you can substitute. Here you can substitute AT equal to alpha. Finally you will be getting. This is how much? How much you are getting, tell me? Acceleration at point P. So square root of A plus alpha sin theta minus omega square r cos theta whole square plus this is how much? Alpha cos theta plus omega square r sin theta whole square. This is the way to calculate the magnitude of acceleration at point P. They will give the given data. Accordingly, you can solve the question. Clear? So, what is the output here in the kinematics or acceleration analysis in? What is the outline for acceleration analysis in rolling? What is the outline here? Acceleration at point of contact. This is point Q, right? This is the point Q. Understood? Acceleration at point Q. So here, acceleration at point of contact P not equal to 0. Acceleration at point of contact not equal to 0. Point of contact. Acceleration at point of contact not equal to 0. Acceleration at point P equal to how much? Omega square r. And linear acceleration becomes tangential acceleration. Tangential acceleration equal to linear acceleration. Alpha equal to A by R. This is very important statement. You can use this part in dynamics of rolling. Dynamics in rolling. Understood? Are you clear or not? Circular motion. In circular motion, linear acceleration won't come. Now write down acceleration analysis in circular motion. In the rolling, we need to combine both rotation and translation. For translation, A will come. For rotation, radial and tangential acceleration will come. Next slide now. Acceleration analysis in circular motion. Acceleration analysis in circular motion. acceleration analysis in circular motion. In the circular motion, we need to treat the body as a particle. Acceleration analysis in circular motion. Circular motion. What is the difference between rotary motion and circular motion? Rotary motion and circular motion. What is the difference between rotation and circular motion?
From fixing point.
Here, see this. Sun. Okay na? Sun. Here to here. Earth. This is earth. Rotating along elliptical path. Clear? So here you can see, if you see from the top, it is in the circular motion. Here, earth. So here, this is earth. Earth rotating about itself with the angular velocity omega. Earth. This is angular velocity of the earth. So here it is rotating with respect to, this is the angular velocity with respect to sun. Understood? So it is rotating about itself. This is a rotary motion of the earth. Rotating about itself. This is what? Rotary motion of the earth. Rotary motion of the earth. So in this rotary motion, earth treated as a body. In the rotary motion, earth treated as a body. Earth treated as a body. Or rigid body. Clear? Velocity at any point on the earth is not same. Velocity at any point on the earth is. Velocity at any point on the earth is. Velocity is different. Velocity is not same. Velocity at any point. Velocity at any point on the earth is not same. Because it is rotating. Earth is rotating here to here. Earth is rotating about itself. Okay na? So it is the rotary motion. So what is the velocity at this point? R1. This is V1. If it is rotating like this, here it is velocity V1, here velocity V2, somewhere R2, velocity would be V2, this is V3, somewhere velocity would be V4, R4, R3. Understood? So at different points on the body, so velocity is continuously different. Velocity is different at different points on the earth. When you consider rotary motion of the earth, in that case, this earth treated as the rigid body. This is related to what? Circular motion of the earth. This is related to what? Circular motion of the earth. Circular motion of the earth. This is what? Circular motion of the earth. In that case, in that circular motion, earth treated as the particle. Earth treated as the particle. Earth treated as the particle. Treated as the particle. That is why velocity at any point on the earth is same. Velocity at any point on the earth is same. Velocity at any point on the earth is same. Clear? So this is the circular motion. Circular motion. So here center of rotation, earth treated as the particle. Velocity at any point on the earth is what? This is r omega. This is omega. Understood? So it is rotating. This is the circular path. This is the circular path. Particle follows along the circular path. Circular path. Particle follows. This is the body. This is the body. Body rotating. Particle rotate. Particle is in circular motion. Particle is moving along the circular path. That is circular motion. When the particle moves along the circular path, then that particle is under circular motion. In that case, we need to consider that body as a particle. Velocity at any point on the body treated as particle. That is why velocity is same. Understood? So when you apply kinematics of earth in circular motion, we need to consider the earth as a particle. When you consider the earth as a particle, velocity at any point on the earth is same. Velocity at any point on the earth is same. So when you apply rotary motion of the earth, velocity at any point is not same. So we need to treat the earth as a body. In the rotary motion of the body, circular motion of the particle, rotary motion of the body, circular motion of the particle, body will rotate, particle will follow the circular path. Even the body is moving along the circular path. We need to consider that body as a particle. We need to consider that body as a particle. Are you clear? Understood? In the circular motion, centrifugal forces will come. Centrifugal forces will come. We already discussed that part. Centrifugal force always act opposite to the direction of centripetal acceleration. Centripetal acceleration is called radial acceleration. Understood this? In the rotary motion of the earth treated as a body. Body means velocity at any point on the earth is not same. In the circular motion of the earth treated as a particle. Okay, now if we treat it as a particle, velocity at any point on the earth is same. Circular motion means particle moves along the circular path. Particle moves along the circular path. Completed. Now. 10:25. Okay. 5 minutes. Focus here. Focus here. Thus, we already done this part. This is the circular path. Circular path. Particle. Here it is how much? This is center of rotation. Particle moves. along the circular path. This is the particle at this particular instant, at this particular instant, at this particular instant. Clear? So particle moves along the circular path with alpha is the angular velocity. This is the radius r. It's a circular path. It's a circular path. Circular path. Circular path. So what is the tangential acceleration? It always at center of rotation. Always at center of rotation of the circular path. Center of rotation. This is the center of rotation. Center of rotation. We already done this part in acceleration analysis in rolling. Center of the this is center of the circular path. Radial acceleration. Tangential acceleration always at tangentially in the same sense of alpha. This is tangentially. This is tangentially. Tangentially. This is how much? Tangentially. Tangentially. Here is how much? Tangentially. It acts tangentially. Are you following? So this is the point P. This is the point P. You can take point P. Whatever. Point Q. Point P. This would be point Q. So point A, point B, point C. Understood? Here to here. This would be how much? Theta. This is also theta. This would be 90. This is 90 minus theta. What is the acceleration at point Q? Acceleration at point Q. Acceleration at point Q. How much will come? Tell me. Here it is. Tangential acceleration. Tangential acceleration. This would be radial acceleration. Radial acceleration. Here to here. 90 minus theta. This would be theta. So this would be theta. Then AT cos theta. AT cos theta. AT sin theta. AT sin theta. Understood? Otherwise it will come downward only. Okay. So here this is how much? AR cos theta. AR cos theta. This is how much? AR sin theta. AR sin theta. What is AQ bar? What is AQ bar? Tell me. AT sin theta minus AT sin theta minus AT sin theta minus AR cos theta. AR cos theta. I cap. AR sin theta plus AR sin theta plus AT cos theta minus J cap. Clear? What is AQ? Square root of alpha sin theta. This is alpha sin theta minus omega square r cos theta whole square plus this is how much? Plus omega square r sin theta plus alpha r cos theta whole square. If they give given data, the things will become very simple. Okay, so what is the acceleration at point B? Point A. This is the acceleration at point A. This would be acceleration at point B. acceleration at point B, acceleration at point C. Clear? What is the acceleration at point B? So in most of the cases, okay na, entire story. So acceleration at point A, acceleration at point B, acceleration at point C and point B, acceleration at point C and point B, that equal to how much? That equal to how much? Radial acceleration square plus tangential acceleration square, that equal to how much? Omega square r, omega square r whole square plus alpha r whole square. Clear? That is the net acceleration. Are you following? This is all about acceleration analysis in circular motion and rolling. I am done.